Okay, class, so this is our last lesson on complex numbers. Okay, and we're going to be multiplying and dividing. So go ahead and pause the video, get your bell ringer done, get it submitted into Canvas or through Remind for the bell ringer for February 6th. So go ahead and pause the video and then we'll move on with the lesson. Okay, so you should have submitted your bell ringer. So let's take a look at what we're working with today. We're going to be multiplying complex numbers because that is actually how you divide. So let's go over specifically how much you remember about multiplying complex numbers. Okay, now we do this just like you do your bell ringer where you have to distribute. Okay, and I do distributing like this, whether it's for polynomials or complex numbers or anything else. I do the box method. Keeps me from forgetting anything, and it allows me to see my like terms. So 4 times 5 is 20. 5 times negative 1, or negative I rather, is negative 5i. 2i times 4 is 8i. And 2i times negative I is negative 2i squared. Okay, and then we have to remember that I squared is actually negative 1. So that's really negative 2 times negative 1, okay, which equals 2. So it sort of cancels out the sign of whatever number you had before, and it goes ahead and it makes it the opposite sign. So now I can combine my like terms. I have 20 and 2, and that's going to be 22. And then I have 8i and negative 5i, and that's going to be 3i. Now, see, we still have to write this in that same a plus bi form that we've been talking about, okay? That's how you're expected to write your answers. So multiplying these two complex numbers, you should get 22 plus 3i as your finished term. All right, so let's try another one. Again, I do these using the box method to make sure I don't leave off anything. Another method that I have seen people use is called double distributing. And that basically looks like this. You're going to do negative 3 times 2 minus 7i. And then you're going to do I times 2 minus 7i. And that's fine. And then you just, again, combine your like terms. If you do the double distributing, you're going to get negative 6 and 21i. So, because, you know, you're distributing the negative 3. And then you're going to get 2i, and you're going to get negative 7i squared. Okay, and that's, again, just from distributing the I. And then go back and do your simplifying. Since I squared is negative 1, like I said, it's basically like negative 7 times negative 1. It takes this term and changes it to whatever the opposite sign is. So in this case, it's a positive 7. So I have negative 6 and positive 7, that's 1. And then I have 2i and I have 21i, so that's going to be 23i. Okay, and we're going back over this because we don't actually divide when we're dividing complex numbers. We actually multiply by the conjugate. Okay, and this is something that you did last year in Algebra 2 or last semester, depending on whenever you took it, for those, you know, juniors that are doubling up to take a higher math next year. But you did this in Algebra 2. So 1 plus 23i is the finish set for this. So let's keep going. Okay, so as I stated, we don't really divide. We multiply by the conjugate. Well, we need to remember what a conjugate is. Okay, when you're talking about a complex number, the conjugate changes the sign of just the imaginary. Okay, so change the sign of just the imaginary. You don't touch the real part of the number. It doesn't change at all. What happens basically is if you change the sign of your imaginary term, okay, those middle pieces cancel each other out, right? And then you're left with basically just a whole number. So when you multiply a complex times its conjugate, you're getting rid of the imaginary piece of it. It sort of gets rid of it for you. Okay, and that's kind of important because when you're dividing by complex numbers, you don't want to have a complex number left in the bottom of the fraction. Okay, and this kind of gets rid of it for you. Okay, so it gives us a real number answer. So the conjugate of 2 minus 3i is 2 plus 3i. And if you multiply them, again, double distributing or however you do it, 2 times 2 plus 3i will give you the first two answers, 4 and 6i. And then negative 3i times 2 plus 3i will give you the second set. That's a negative 6i and a negative 9i squared, right? Okay, so because the I squared is negative 1, that makes this equal positive 9. So you're left with 4 plus 9 because the positive 6 and the negative 6 cancel. So multiplying it results in one single term, and it's a real number. There's no more imaginary pieces to it. So very, very important to remember how to write a conjugate, okay, and to be able to use it. All right, so that being said, let's go ahead and do another practice just to make sure you've got it. So the conjugate of 4 plus 2i, again, if you want, pause the video, see if you can figure out what the conjugate is and multiply it, and then come back and, I'll work it out. Okay, so if you paused it, the conjugate of 4 plus 2i is 4 minus 2i, again, only changing the imaginary part. And if I distribute them out, either box method or double distributing, doesn't matter which, okay, I'm going to get 16 plus 8i, and then negative 8i, and then negative 4i squared when I do negative 2i times positive 2i. Again, middle terms cancel. Negative 4i squared becomes positive 4. The answer to this statement as far as multiplying by the conjugate is just 20. That's all you should get. Okay? And if you notice, what's really happening because the middle terms cancel is you're getting the first term squared plus the second term squared because of the middle pieces canceling. That's really what it's going to be when you multiply a complex times its conjugate. Okay? It's kind of a little shortcut if you remember it. If not, do the full multiplication and you should always end up with just a real number when you do this. Okay, so let's apply this to actually dividing. Okay? So as I stated, we do not really divide complex numbers. It's sort of like saying we don't really divide by fractions. We multiply by the reciprocal. Okay? When we have complex numbers, we multiply by the conjugate of the denominator. We don't actually divide. So your conjugate is 6 minus I. So showing this as a setup, you're going to have to multiply both the numerator and the denominator, because think about fractions. Whatever we do to the bottom, we do to the top. We have to keep it the same, right? And you're going to multiply both times the conjugate of the denominator. So that being said, my fraction originally is 5i over 6 plus I. So it's basically 5i divided by 6 plus I. Okay, so then I'm going to multiply the top and the bottom by 6 minus I. Okay, and I'm going to have to multiply them separately because it's two separate pieces. Now, if you remember the shortcut for the bottom, right, when you multiply them, those middle pieces are going to cancel. What you'd be left with is 6 squared plus 1 squared, because those are 1s in front of those i's that we have there, right? So if you remember the shortcut, it's just going to be 37. If you don't, and you actually multiply out the bottom, you're going to have 36 minus 6i plus 6i minus I squared. And it cancels the same way. Remember that I squared is negative 1, so that's like negative negative 1. It becomes plus 1, and those cancel. So you're left with 37 in the bottom of your fraction. So now we need to distribute the top. Okay, well, we only have one term here, so it actually shouldn't be that bad. We just go ahead and distribute it. That's going to be 30i minus 5i squared. Okay, so we need to simplify it. It's got an I squared in it, no big deal. That becomes negative 1, so that becomes positive 5. Write it in the correct order. Real number first. So that's 5 plus 30i all over 37. Okay? So again, conjugate, top and bottom. Distribute out the top since it's only got one piece in it. Either multiply out the long way or remember your shortcut. that this is really just 6 squared plus 1 squared. And that's what you're going to get in your denominator. All right, let's try another one. Okay, and again, pause the video if you want and work through it and then come back and see if you get it right. So the conjugate of this one, well, remember that if it only has the I piece, it's like saying 0 plus 5i. Well, we're only changing the imaginary number, right? So the conjugate of that is just negative 5i. And again, top and bottom. All right, let's distribute it out and see what we get. Because this is only the one piece, it makes it kind of nice on the denominator. This is just going to be negative 25i squared, which everybody should know that that is going to be now a positive 25, right? All right, so let's distribute out the top. That's negative 5i times 4. That's negative 20i. And the second piece is going to be negative 10i squared. And again, simplify and write it in the correct order. This is going to become positive 10. This is going to be negative 20i. And yes, we really do need to simplify that. You need to figure out what you can divide 10, 20, and 25 by. And in this case, you can divide them all by 5. So that's going to be 2 minus 4i all over 5 if you divide everything by 5. You do need to actually simplify these down as far as you can go. All right, so the next one, 3 minus 2i, the conjugate is going to be 3 plus 2i, top and bottom. And this one's actually going to be a long one because we have to distribute out everything. Okay, so again, the bottom one, if you remember the shortcut, it's really just 3 squared plus 2 squared, right? Because everything else goes away and the I makes it positive. So that's 13 on the bottom. And then the top, again, we're going to do a double distributing, negative 4 times both and then 2i times both. That's going to be negative 12 minus 8i plus 6i plus 4i squared. Okay, so we need to simplify that. Do your, I squareds and your combining like terms. That's going to become negative 4. So we have negative 12 minus 4, that's negative 16. And then we have negative 8i plus 6i, that's negative 2i. And all over 13. And it's not going to simplify any further. But this is okay because it has a real number in the bottom. Okay, and this is just a review of Algebra 2. Pause the video, go back, replay it as many times as you want, go through the steps, that's fine. Your assignment for this is in the textbook. It's in section 2.1 again, so page 284, 11 through 18 and 21 to 28. You have the rest of the class period and tonight to finish it. It needs to be submitted by midnight tonight into Canvas in the place where it says Complex Lesson 6 assignment. Okay? And have a good day, and I will holler at y'all tomorrow.